Okay, here are my two equations. Y less than or equal to 5, x greater than negative 3. Before we graph, let's remind ourselves, y equals, this is a horizontal line, so I'm going to write h for horizontal. X is greater than a number, that's a vertical line. So at least you know kind of in your mind what they're supposed to look like. Horizontal, which way does he go? Left to right. Vertical, which way does he go? Up and down. Before you graph anything, you should always have a picture of what it should look like in your head, at least the lines part. The shading part is a little tricky. So next we want to determine, are you solid or dotted? This guy right here, y less than or equal to, since it has an equal to sign, it is solid. This guy is just less than, without an equal to, he is dotted. And before, remember I said dotted, dash, broken. It just depends on the editor of the software, okay? So now let's graph. Let's go to the horizontal line first. Y is less than or equal to 5. So here's my origin. Let's count to 5. 1, 2, 3, 4, and 5. Let's put our dot. And remember, technically it takes 2 points to make a line, but when you're drawing horizontal and vertical lines, you don't need 2 points. You only need 1. You know that he's a solid line. He runs left to right, so let's draw that. There we go. Okay, now let's do our vertical line. Our vertical line says x is greater than or greater than negative 3. Go back to the origin, go to x equals negative 3, negative 1, negative 2, negative 3. There it is. And it's dotted or broken, so let's do that. Draw that line. Okay, and there we go. So here are our two lines. This is our system. Now, if I was asking you to, quote, solve this, the point where the two intersect, that would be called the solution. But I'm not. I'm asking you to shade because I want anything that's greater than, anything that's less than, that falls into both. So let's see where I'm shading now. Let's look at my horizontal line. Here it is. It's in blue. Less than. Where are the numbers less than 5? They should be down here, right? So with blue, I'm just going to make marks like this. I'm going to show you like that, all right? Then, if I want greater than negative 3, where do you think on the x-axis numbers would be that are greater than negative 3? Yep, they're over here, aren't they? So let's do this. Shade, 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 shade. Okay, so that takes care of that part. Now, I'm not done because I want the solution set to this. What that means is I want something that is shaded not only in blue, but shaded in red. So in order to do that, let's pick our test point. Our test point, let's pick something down here, shall we? Let's just randomly pick this number. That's going to be x is positive 4, y is positive 1. That's my ordered pair. So let's see if we've got the correct area for my solution. My x value is positive 4, so let's plug it into right here and let's see if this is true. Is 4, positive 4, greater than negative 3? Is that true or false? It's true. Okay, so far my x value is good. Now let's try the y value. The y value is positive 1. Is positive 1 less than or equal to positive 5? Is that a true statement? It is. This is also a true statement. Because both of my statements are true, that means I'm shading the correct area right here. So I know maybe it's going to be hard to see, but you see all of this? This whole little quadrant down here is where you shade. This is your solution set because it is what's less than 5 on the y-axis. At the same time, it's also greater than negative 3 on the x-axis. So that's what solving the solution to the system means. I want what is shaded by both. Okay? All right. Come back because I'm going to do a couple of more examples for you, all right? See you at the board.